Okay, when you're graphing quadratics in the form y equals ax squared plus bx plus c, it is not like just graphing the ones without b, because b causes that horizontal shift. Okay, you're not going to be able to pick anything out specifically from that equation that is going to tell you where your vertex is. And the problem here is if you just use -2, -1, 0, 1, and 2, that will give you part of your graph, but it might not give you the vertex. And it's going to save you a lot of time if we start by finding the axis of symmetry and the vertex. So part 1 of graphing quadratics in this form would be to find the axis of symmetry and the vertex. Because if we can plug the vertex into the middle of our table, then we can choose points that are around the vertex, and it's going to save us some time. Because that horizontal shift means that our vertex is no longer centered on the y-axis. Okay, so there is, I can show you at some point where this is derived from, but your axis of symmetry, we know from previous discussions that the vertex is on the axis of symmetry. That is the center of your graph, and that's the imaginary line that goes through the center. We can find that with the equation x equals -b over 2 times a. So we're going to look at an example to walk you through this. Okay, so this is going to be our example. You're not going to plug anything in for x because that's what we're looking for, is what is the line that goes through the middle of the parabola. Okay, remember that that is a, that is b, and that is c. Okay, so we're going to pick those values out, plug it in here, and simplify, which will tell us where that vertical line should be, or where it should cross the x-axis. So we have x equals, b is 6, so we have negative, and you might want to use parentheses when you're plugging stuff in, because if you plug in a negative, then that negative is going to change. Okay, but b is 6, and c, or a, is -3. So we plug it in and simplify. So on top we have -6. On the bottom we have -6. And if that fraction can be simplified, then you'll want to simplify it or change it to a decimal in some cases. Yep?
So it would be negative no matter what on b?
Yes. The negative is going to always be there, but if you plug a negative in, so if b is negative, then you're plugging a negative in to something that was already negative, that's when it'll turn positive. Okay? So that's why I'm saying use parentheses. That way if you plug a negative in, you're going to see that you have negative. Okay? And that'll cue you in that you've got to change that to a positive. So -6 over -6 equals 1. So my axis of symmetry should be the vertical line that crosses the x-axis at 1. So my parabola would be shifted really 1 to the right of the y-axis. Okay? Now, in order to find the vertex, because that's going to tell us where specifically the bottom or the top point of our parabola is, we're going to take that value and plug it back in, because we know what x is.
Every x? Or just
Every single x. Okay? So the second step is plug x into the equation and follow order of operations to simplify. All right, so using this part, we want the y value. Okay, we're going to say y equals -3, put parentheses, so you're going to plug in 1 squared plus 6 parentheses with the 1 plus 5. Now I know that there's some people that think that they can do all of this in their head. Those are the people that usually get it wrong. Just the first step would be just plugging it in with parentheses, okay? The second step that I would recommend here is simplifying one term at a time, and then you're going to add or subtract accordingly. The people that follow those steps are usually the ones that get it right. Again, people that do it in their head usually don't get the right answer out. So right here, I have 1 squared times -3 gives me -3, yes? So that's -3. The second term is 6 times 1, so just 6. And the last term was 5. And then all you're going to do is combine those three numbers, okay? So -3 plus 6 is +3 plus 5 is 8. Okay, so y is 8, and my vertex should be at 1, 8. Okay, so the vertex for that equation is at 1, 8. Now go back up to your original equation. Do you see 1, 8 in that equation anywhere? That should tell you you're not going to be able to look at the equation and know where that vertex is. Your horizontal and your vertical shift still happen, but they don't look like this, okay?
So we just graph those points?
So you're going to graph 1, 8 as your vertex, but that's also going to help you determine what your table should be. And we're not going to get to the table for the most part today, but I want to show you. If I were to build a table knowing that the vertex is at 1, 8, I would put 1, 8 in the middle of my table and choose x values that are the same distance away from 1, because I know that should be the center of my graph, right? So I would choose probably 2, 3, and 0, -1. Okay, so when I build my table, that is going to be important because it's going to save me time, because I'm not just going to pick random values. You can see if I did what I normally would do with the others and do -2, -1, 0, 1, and 2. In this case, I'd have a decent part of my graph, but it would be a little off center. And I couldn't mirror one point to the other, okay? Because I wouldn't know what the vertex was until I actually graphed them. So this saves you time. So once I calculate the vertex, I'm only going to have to calculate 2 other y values, and the others should be the same, okay? But we're going to focus mainly on just finding the axis of symmetry in the vertex today, all right? Another example, we are going to do, okay, y equals x squared minus 6x plus 9, okay? So we're going to start out with the axis of symmetry, remember, which was x equals -b over 2a. All right, so what is my b value? -6. So notice now I've got a negative, negative, and what is a? What's next to x squared? 1, not 0. You remember from factoring, just because there's not a number there doesn't mean you want 0. A is 1, okay? So the next thing we need to do is simplify. So we have negative, negative makes positive 6 over 2. So what is 6 over 2? 3. So my axis of symmetry is the vertical line that crosses the x-axis at 3. But in order to find the vertex remember I need to plug in x. Okay, so I'm going to take what I have up here, y equals parentheses squared, and I'm going to plug in 3 minus 6 with parentheses plus 9. And notice, like on the last one and on this one, I'm not just plugging things into my calculator. You can do better at this than your calculator. If you don't know the multiplication or you don't know what something is squared, then use your calculator, but you're going to save yourself messing up those signs by plugging in the wrong thing. You don't want your calculator to do all of this for you, because if you hit one wrong key, you're going to get a wrong result. Garbage in, garbage out, right? Okay, so what is 3 squared? 9. Negative 6 times 3 is negative 18, plus 9. And if you notice, I mean, as long as you know this is negative 18, you can do some of this in a different order. I look at this and say, oh, 9 plus 9 is positive 18. Minus 18 should be 0. So if you group things that work together better, by all means. So that's your y value. So what should my vertex be? 3, 0. Okay? So that parabola of mine, which is going to open up because it's positive x squared, the vertex is going to be over 3 to the right. Okay? So if I, again, chose negative 2, negative 1, 0, 1, and 2, I'd only see half of my graph. I wouldn't see the whole thing. Where if I build it around 3 being the vertex, then I'm going to get the right points, save myself some time. Okay? So I'm going to have you guys try one that is actually on your homework.
So for our homework, you just want to go that far?
Just that far. It says in the book, graph. You're not going to graph right now, okay? All you're going to do is find the axis of symmetry and the vertex, and you might get a decimal or a fraction, okay? In fact, I guess we'll do one more. We're going to do number 26 to show you it's not the end of the world if you get a fraction or a decimal, okay? Where it is a little bit of a pain is building your table around it, but we're not going to worry about that today, okay? All right. So what is my B value? 1, and A is 2. Okay, so on top I have negative 1, and on the bottom 4. Okay, now for the sake of plugging stuff in, if you're not good with fractions, you may want to turn this into a decimal. So what's a decimal of 1/4? So negative 0.25 is what I'm going to plug in. And this is where if you get a fraction or a decimal for x, you may want the help of your calculator, but only do one term at a time still. Okay, you don't want to mess up by trying to plug it all in. Most calculators don't like that. So the vertex, we still need to find y. So we're going to do 2 parentheses negative 0.25 plus 0.25 minus 3. Or negative, sorry, that should be negative. And that's squared. So using your calculator, if you need help figuring out what the squared version is, okay, that's when I would suggest your calculator. So 0.25 squared is, yep, but when you square negative, what happens? Becomes positive. So if that negative is inside, you really don't even need to put it in the calculator, because when you square it, it's going to be gone, yes? So I get 0.0625, but I have to multiply that by 2. So that is 0.125 minus 0.25 minus 3, and now you can use your calculator to put in that string of values. So 0.125 minus 0.25 minus 3 is what?
Negative 3.125.
Negative 3.125. That's my y value. So what is my vertex? Yep, it's xy, so negative 0.25 and negative 3.125. Okay, now this is the reason we go through this process, because if you picked negative 2, negative 1, 0, 1, and 2, would you ever see the vertex? Would you know exactly where it was? You'd probably not guess in a million years that that was your vertex, okay? You'd kind of have the graph around it, but a lot of people have a graph that looks kind of like you, and then it's got a flat spot at the bottom because they didn't know exactly where the vertex was. That's why with these we don't just randomly pick points, because you need the vertex on every graph to have a true picture of that function, okay?